Hello class, good to see you again. So I have a question. Has anybody here seen the movie Mean Girls? Great, that's wonderful. So you guys already know that there is a thing called a limit, right? And sometimes limits don't exist, but sometimes they do, and that's what we're going to get into. But first we need a little bit of a conceptual understanding of what we mean by limits. And to do that I want to backtrack just a little bit. So I've drawn a function up here, and I wanted to know if anybody could identify what this function is. Yeah?
That's the 1 over x function.
Perfect. This is f of x equals 1 over x. So on this function we have, two different parts with a vertical asymptote through the y-axis. So I'm going to do a little demonstration and start around the point x equals 0 and start moving to the right. So I'm increasing the x value slowly along this axis, and I want you to tell me what you think is happening to the y value as I'm going along. Getting smaller, okay. So how small exactly does it get?
Really, really small.
Really, really small.
Infinitely
Does it get negative? Because that'd be really small. No? What is the smallest value it can be?
0.
No.
Can it be 0?
No. Point zero.
That's
It
positive.
cannot. It cannot actually reach 0, but it can get very, very close if we go into extremely high values of x. Alright, so now that we've examined that function, I want to look at another extremely familiar function that you all know. Looks something like this. Who knows what that function is?
Y equals x squared.
Perfect. I'm going to write f of x. F of x equals x squared. So we've now looked at what happens when we're moving across the x-axis to the right, but for this one I want to start at the point x equals 1 and start moving left. So as I move left across the x-axis, what's happening? It's getting smaller. Okay, and then right when I get to 0, what starts happening with this graph?
Bigger.
The y value is getting bigger. Okay, so if I keep decreasing the x value, the y value continues to get bigger. So what's the biggest the y value can be if I move farther and farther to the left?
Infinity.
Yeah, it could just go off forever. There's really, some would say that there's no bound to how great the y value can be. And that's the idea of the limit. So basically in English, what do you think about the word limit?
Something you can't do.
Something you can't do, yeah, boundaries. Some would say a restriction. So in math, it's sort of the same thing. And when we're talking about limits, we're talking about a restriction. And in this case, what I was asking you is, I'm making my restriction on the x value negative infinity. So the restriction is negative infinity, but what we want to talk about is what happens when you approach that restriction. And our notation is this. The limit as x approaches negative infinity of x squared equals, who thinks they know the answer to that? Sure.
Is it infinity squared?
That is a good guess, because what Taylor's doing is taking this negative infinity and plugging it into the function, and you would think that, well, the negative goes away because it's a square, and you're left with infinity squared. But that's a concept that we also want to explore. What is infinity squared?
Infinity.
Right, because we don't yet have a concept of a number greater than infinity. So infinity squared is also just infinity. Thank you for that. So now I'd like to go back to this function. What do we have over here? I was going to the right, which means what is my restriction on the x value if I'm saying as far right along the x-axis as we can go?
Positive infinity.
Right. The limit is x approaches positive infinity of 1 over x. And somebody thought they knew the answer earlier. Did you have an idea of what that was?
Infinity?
Okay, so x value is getting closer to infinity, and as we're going along this axis, the x values we decided were getting
Oh.
smaller and smaller.
0.00 whatever. Very
Yeah.
close to 0.
It's very close to 0, and that is the exact concept I'm trying to illustrate, is that when we take the limit, not only does it get really close to 0, but the limit is actually 0. Thank you very much.